Alright, Colts, welcome back. This is going to be 1.2 notes. I'm going to split them into the vocab and then the examples just because the videos are too long or just there was an error uploading it on YouTube. So starting off, we're going to have our line segment. And it can be measured because it has two endpoints. So if we create our line, we have an endpoint here, an endpoint here. Maybe we label it X and Y. So we don't have our arrows on the end, and the way that we label this is XY or YX. All right, betweenness of points. We're going to go over kind of both of these, but when I'm talking about betweenness of points, it's like I have a line, and I'm just talking about how there is something, if there's another point or something in between. So maybe I have two numbers. I have A, I have B, and N excuse me, is somewhere in between. So it's just showing me that N is greater than A, but smaller than B. Well, when we're talking about between a point M, so we go to our next definition, is between two other points. So if I were to draw this, here we'll do A and we'll do B. I want to make sure we understand clearly about betweenness of points, that it's not the same as a midpoint. So a lot of times they'll put it here and they'll say M, okay? But I want to make sure when we do this one that I don't label it there. So maybe I'll put it over here and I'll put it closer to the B and I'll label this M. So betweenness of points is just saying that these points, this M is in between A and B, but not necessarily at the center. Okay? So it's really important though for the betweenness of points that we see that if I take the two smaller pieces, so if I say segment AM and I add it to segment MB, that it's going to equal the total of my whole segment. Okay? Alright, moving on to the next part. I want to make sure we understand as well that AB is this length here. Okay? Alright, going down to congruent. The two geometric figures are congruent if they have the exact same size and the same shape. Okay? The symbol that we use for that is like an equal sign, and I like to say it has like a little toupee or some fancy hipster hair. But that is the symbol we're going to be using for congruent. Okay? So for instance, if I said that segment XY is congruent to segment AB, that means segment XY and AB have the exact same size and the same shape. Okay. Next definition we're going to talk about is rigid transformation. It's a transformation in which the position of an image may differ from the pre-image, but they remain congruent. So it's like if I had a triangle, for instance, if I did this. Let's see if I can get my computer to work. Let's do this. And if I took this guy and I turned it, right? So it's going to have the same size and shape, but it's been oriented differently. Okay. And we're going to have a lot more in depth about transformations when we talk about them. Okay, congruent segments, okay, are going to be if one segment can be mapped onto another segment using rigid transformations, they have the same measure. So if I have one segment, I'll call that segment AB. And then if I have another segment, we'll say that's CD. If I say that these segments are congruent, so it's often signified by a little tick mark in the middle. And sometimes it'll even be like a double tick mark if there's more than one. But in this case, we're just going to have one. That tick mark signifies that these segments are congruent. So therefore I can say, this was our segment CD, I can say that segment AB is congruent to segment CD. Okay, just to give us some notes, we're going to say the tick mark means they are congruent. All right, going on to our next one, construction. So we're going to have an activity where I'm going to have you guys use a compass and a straight edge, protractor, things like that, and you're going to do constructions where you're going to create figures using pencils, straight edge, and compasses. So it's like if I gave you like an angle, or had you create one with your compass and protractor, okay? Then I would have you, like, using those tools, have to duplicate it. So we're gonna have an activity, but it's just using those tools to help us to create, whether it's congruent segments or congruent angles. But we'll have a little more further detail when it comes to that. Okay, distance formula. So the distance formula is gonna be between 2 points. So if I label x1 and x2, I'm gonna keep my x's together. And then if I have my y's, I'm gonna keep my y's together. So I'm a firm believer in application over necessarily not like memorizing formulas. So the formula, starting off though, we'll just do is the difference between our x's. So if you remember, right, difference is subtract. And so you could do x2 minus x1 plus the difference in our y's. So y2 minus y1. If you mix these up, okay, it's not a super big deal because if you square it, okay, it's still going to give you the same distance between those 2 points. So we're going to try this example. Well, let's draw it out first. So let's see. If I have a segment here, and I label this one P, and I label this one Q, okay. This is like my x1, my y1, this is my x2, my y2, okay? And I would label this segment PQ. So oftentimes if they ask you to find the distance of something, they're gonna say things like find PQ. It's gonna be written just like this. Nothing on top, just like so, okay? So if you see find AB or PQ or BC without a line segment or anything on top, and generally it's sometimes they're capital letters, that means you're going to find the distance. So you can plug them in, you can use the formula. We'll have some examples at the bottom, but I also want to talk about another way to do it, and it'll be based off some of the skills that you already know. So if I had a coordinate plane, okay, and I had 2 points. So let's say that I have the point P and it is 2, 3, and Q is 5, 1, right? So I'm gonna graph them. 1, 2, 1, 2, 3. It's not gonna be super pretty or accurate because I don't have graph paper, but we'll do the best we can. 3, 4, 5, 1. So this is gonna be our P. This is gonna be our Q. I'm going to draw a line through our 2 points. And I want to find this distance. Okay, so there's a couple ways you could do it. You can take these values and you can plug in your y's to your formula, and you can plug in your x's to your formula. Okay, generally we start with x's first, y. I like to have you guys label them, x1, y1, x2, y2. It just helps you keep track. Okay, so you can use the distance formula. You can take them and you can say, all right, d equals, and you plug in your stuff and you solve. Or up in our coordinate plane up here, we can draw lines in such a way that we create a right triangle. If we create a right triangle, now the diagonal that's green, it's hard to get that measurement, but you can tell me how long this side is. So let's do it a little thinner. Right here, right? So if this coordinate, if this y value is 3 and this y value is 1, we say, okay, well, what's the difference? Well, from 1 to 3 is going to be 2 spaces, right? So that's 2. If I go from here to here, and I'm at let's use a different color. We'll go back to our purple. Here I'm at 2 and here I'm at 5. I say, okay, how many spaces is that? It's going to give us 3 spaces. Now when we have graph paper, it's going to work a little bit better. But because I'm able to find the length of those 2 sides, I can use my Pythagorean theorem. Okay, and if you remember, c squared is always the hypotenuse. So in this case, our hypotenuse, okay, is what I colored green. It's always across from the 90-degree angle. So when I plug in my a and my b, the legs, it does not matter which one goes where. So I can say 2 squared plus 3 squared equals c squared, and then I would go through and I would solve. So I'd have 4 plus 9 equals c squared. I'd end up with 13. I'd take the square root, and I end up with this side being the square root of 13. Okay. If I went down here and I did this one and I plugged in my x's and my y's, if I did 5 minus 2, and then I did 1 minus 3. If I went through and I calculated, 5 minus 2 gives me 3. It's going to be squared. Plus 1 minus 3 is going to give me negative 2. It's going to be squared. If you see here, get a highlighter to help you. 2 squared, 3 squared, 3 squared, negative 2 squared, but negative 2 squared and 2 squared are going to give us the same thing. And we end up with the same calculation. Square root of 13. So either way works. So sometimes it's going to be, you're going to have the coordinates. Sometimes it's going to be better if you visually see it. Sometimes the distance formula is going to be better because maybe you can't count exactly. So that's our example for distance formula. So we're going to jump down to irrational numbers. Irrational numbers, I just want to make sure you're understanding, it's a number that cannot be expressed as a terminating or a repeating decimal. So if I gave you 0.25, let me make our pencil a little bigger. 0.25, you can write that as a fraction, or vice versa, okay? Or like if I said 1/5, you could write that, okay, as a terminating decimal or something. Or the other option we have is repeating. So like if I had 1/3, right, it'd be 0.3333 repeating. But an irrational number is going to be a number that we cannot write in that capacity. So if I took numbers like pi, I cannot write this as a fraction. Okay, same thing with the square root of 2. Okay, it gives me a decimal, but I cannot write that as a fraction. So those are some of our examples of irrational numbers. All right, in the next video, we'll have our examples.